welcome to Unapologetically Technical. My name is Jesse Anderson, and this is the show It's Different. We go deep, we go all the way down. With me for the first time ever in the history of this show is physically in person, Adrian Woodhead. And I've known Adrian for quite some time. He is now a distinguished software engineer at Human. Welcome to the show and to Portugal, Oerias, Portugal, Adrian. Would you mind introducing yourself a bit more?
Yeah, thank you very much, Jesse. It's really good to be here, like you said, in person. I was expecting we would do this over some video conferencing thing. That's so much better to actually be here physically. Beautiful view outside, beach, sea. So thanks for having me.
Yeah, this is, as a bonus, I'll turn the camera around at some point so that you can see this. It's not as beautiful a Portuguese day, but we're right by the ocean and you can see the ocean. So let's talk about your background and some of the things that you've done. But first, I want to ask you, since you have such a good background in this and a long background, what has surprised you about how the industry has changed over time?
What time period are we talking here?
Any time period you want, because, well, actually, I would say it's important because we'll talk about it later, but you go almost all the way back to the beginnings of Hadoop.
Yeah. I guess one of the things when I sort of, I wouldn't say stumbled into it, but got involved in this right back then, it was a very focused on like a certain use case, certain type of data. And then having worked in different companies over the years, it's just amazing how so many companies are actually at their core data driven, and how a lot of the principles actually are exactly the same regardless of what the company does. So I think that's been an interesting journey for me, because I've always thought, I work for a music company or a travel company, but it's actually, I do data, and the type of company doesn't really matter that much. If they're big enough, they've got enough scale. It's the underlying principles of the data that's actually pretty much the same across all of them. And it's just a different way of thinking. It's like you're not actually working for a company that does something. I mean, obviously they do something, but as like a data professional, you're almost abstracted away from some of that. And I found that reflecting on it at a certain point in my career, I was like, wow, it's quite cool, because your skills are transferable across so many different industries that do so many different things, but they all need to organize their data and try to get value out of it.
Yeah, that's interesting. As much as they're different, the more things change, the more they stay the same. Is that kind of what you're thinking?
Yeah, and I've seen a lot of companies that maybe in the past wouldn't have considered themselves data-driven, but in the world we live in now, they realize their data is where they get a lot of their value from. So this suddenly becomes like a really valuable thing. And maybe they were even doing it in the past, but they didn't really think about it that way, and now they do.
Well, that is interesting. So let's go all the way back in your career. You started your career, well, we were talking about it before, and all the time I've known you, I didn't realize you were originally from South Africa. So you started your career at a company called Shift Interactive Communications as a software developer in South Africa. I originally had this question about I thought you would move from UK to South Africa.
Yeah.
No, you were just starting out there. So
Yeah.
I haven't talked to many people from South Africa at that time. What was it like as far as the software and technology scene?
Yeah, it was, so that was like 1998, 1999. This company started, it's almost like this classic example of a startup, but I didn't realize it at the time. It was my next door neighbor had a garage, and they basically started their company in the garage, like the famous Silicon Valley stories you hear, right? But this is Johannesburg in the 90s. So they started the company in the garage. I was still studying at university, and they tried to actually get me to leave university early to go work for them. And I said, no, let me finish my degree, started this, but wait, I'll come. And then when I finished university, I worked for them. But by then they'd moved into like a little office building, really nice. And it was run by a startup incubator. I mean, it didn't have that name then. It was just investors. And they had, I think, 3 different companies in the building. It wasn't a big building, but they were all startups doing different things. But their commonality was they were all funded by the same group of people. So a lot of those things are actually almost like the blueprint for like startups and how things work, just happening there in Johannesburg.
And so how did that pan out for you?
So the company was very successful for a brief period of time. So their specialty was doing software for touchscreen kiosks. And it was around the time that the iMac came out. So that was the perfect form factor because you could pick it up, carry it around, it looked nice, and they fitted special touchscreens on them. And I mean, if they had managed to last like another 10 years or a bit longer to where we are now with touchscreens and all the devices, this company would have absolutely smashed it because they were so far ahead of their time in terms of user interface design and interaction with the touchscreen. But back then, you could only do that on these specialized, very expensive screens fitted onto a computer. It wasn't something in your pocket or your hand. So, you know, they did well for a while. It was kiosks mainly for trade shows, those kinds of things. But it's a very hard business to really like scale out. So after I left, I think they kept going for another couple of years, and sadly, they no longer exist.
And they just ran out of money or ran out of...
They had like one of these classic situations where, as a very small company, one of their customers was the biggest mobile telco in South Africa. So they had like one very big business unit, and then when that relationship at some point broke down, you've lost like your biggest revenue source, and then it's hard to find another one. So, you know, if you just become completely dependent on supplying one company, that's very risky.
Yeah. Concentration risk.
Yeah.
It's killed a lot of places.
Yeah.
Oh, that's too bad. Because on the other side, sometimes you'll hear the story of, oh yeah, they eventually realized it and decided to buy them.
Yeah.
But sometimes stupid companies will say, oh, I can go do that myself.
Yeah.
Bye.
Yeah, and I mean, for like the mobile, the telco that had us as a supplier of these touchscreen kiosks, I mean, their business is mobile telco, right? They're not going to buy a touchscreen software developer. It was really just, it was part of all of their marketing, and they would have it at trade shows and so on. So it was super cool software, very different, but yeah, unfortunately didn't make it.
Well, that's unfortunate. But how vibrant of a tech scene did Johannesburg have at that time?
Not massively vibrant. There were a few companies like us. I think the biggest, most well-known one is called Data. So they did a bunch of different kinds of companies. I mean, e-commerce was starting, the web was starting. There were definitely like places, you know, you could go to build websites for you. There was a lot of that happening. But most people were doing it in isolation. It didn't really feel like there was a community. There weren't meetups. It was just, you know, a lot of companies doing tech. But it was starting, and there was definitely stuff. I mean, it's a big city. There was, for its time, I guess, quite a bit going on. But if you compare it to where we are now, it was a different ballgame, right?
Very different.
Right.
So from there, you started contracting, and you moved at that point to the Netherlands. What precipitated that move?
Yeah, so what happened there was I was actually very happy. I didn't want to go anywhere particularly, but it was around the time of the dot-com boom, so like 2000. And I think companies were so desperate for tech talent, developers, they were basically just putting their feelers out all over the world. So I started getting agents. I'd never dealt with a recruitment agent in my life, just like cold calling me. I didn't even know how they got my details. You know, it's not like there was no LinkedIn. I don't know how they found me. But they would be like, oh, there's this company in the Middle East that's looking for a Java developer to work on like some Sun Microsystems setup. And that just sort of like planted a seed in my head. I was like, oh, wow, I could take this job anywhere. I hadn't really thought about that. And I've always wanted to travel. And then I actually went on a holiday via Amsterdam where one of my university friends was. And I had such a good time. I was like, oh, I want to move here. And coincidentally, one of the companies via one of these agents that reached out was based in Amsterdam. And my interview with them, it was amazing because they were so desperate for people. My interview basically consisted of, do you have a computer science degree? Yes. Can you fax us a copy of it? Yes. Okay, come. And that was it. We'll pay for your flight, we'll pay for everything. Like they were just so desperate to get someone who could actually program. And it just, all you needed was a computer science degree and a copy of it.
Little did they know. That is interesting. Okay, so just by happenstance, you end up there,
Yeah.
and you were doing a lot of web backends at that time. Is that right?
Yeah. So at the touchscreen company, obviously most of that was a front end. So it was doing front end interaction. But as those applications got more advanced, they wanted to like capture user information. You could also send an SMS from the touchscreen. So that they needed to interact with backend systems. And most of the developers in that company came from animation background, design background. They'd never built anything like this. They'd never interacted with databases. So because I'd studied Java and had some experience with SQL, in that company, I gravitated towards doing the backend services. So then I continued when I joined. So the first company in Amsterdam was a digital rights management company. So it became like a bad term, digital rights management. But when I joined them, like the idea was good. It was about, with the rise of Napster and all of these things, like artists were just losing, they just lost their revenue stream. All of their stuff was being pirated. So that on the face of it, it sounded good. It was like, we're going to build these formats where people pay and the artists get paid. So that's why I joined. I was like, that sounds great. Like, let's even this out a bit. So it was the back end of a digital rights management platform.
Okay. And that was all written in Java at that time?
Yes.
Oh, interesting. Because Java at that time, the cryptography packages weren't that great.
No, so the interactions with the crypto packages, so those were provided by, so there was a big one, which was Microsoft with their Windows Media. So then we had like the Java, C++ bridges. And then another one was actually provided by Real Networks. Remember them?
Oh, yeah.
So we basically just had Java APIs onto their APIs, and they did all of the hardcore crypto stuff underneath it.
You just made me smile because for those of you watching, crypto didn't always mean coins and stupid things like that. It wasn't Bitcoin. Crypto meant cryptography. In fact, the package in Java was Java Util Crypto. Was it Java Util Crypto or is it just Java Crypto?
Yeah, I can't remember. But there was JCE, the Java Cryptography Extensions.
Yes.
We used a lot of that.
Yes. I think it was Java X crypto or something like that. But yes, we've been co-opted by these people with their stupid coins. Okay. So that you take that computer science background and you're gradually gravitating. You're finding that you like the back ends better. What made you like the back ends better?
Yeah. There was some point around that time where, because these companies were smaller, you would have to do like what we now call full stack. But you would do the HTML front end, you would do a bit of CSS. I mean, the designers would do a lot of that, but you would basically take over with the JavaScript that would talk to the servers, and then you would write the servers on the back end. But what got to me was that put me off front end and web development was the browser incompatibilities. Like when I was spending hours like navigating just small differences between like this version of Internet Explorer, that version of Netscape, and just the pain of having all of these if statements and figuring all of this out, I was just like, this is not what I signed up for here. I want nothing to do with this front-end development. And it's also obviously much harder to test, especially then there weren't things like WebDrivers to test the JavaScript. So it was, the only way you could test it was have 5 different browsers and then load your page and click through. It was so time consuming, whereas on the back end, you could write a unit test and you're pretty much done. So I really liked the more predictable nature and the fact that typically you just had to write something once, not for 5 different browsers.
Yeah. That was what front-end development was. It was, if it's IE, that was one of the first things, if you looked at any JavaScript code back at that time, it was figure out what browser you're on and then do all the if statements for that. It was IE, because even the API compatibility was different. Accessing Windows and all different. It was There was no standards.
No, it was a nightmare.
Yeah, and in some ways, well, I shouldn't say there wasn't standards. It was that IE specifically was not trying to adhere to the standards.
Yeah, exactly. There was a standard, but then people implemented it in very different ways.
So you were there contracting in the Netherlands, and then you made a move to the UK. Tell me about that move.
Yeah, so what happened towards the end in the Netherlands, so I'd worked for 2 different companies there, and then I'd done contracting for a bank, a big Dutch bank, and I did that 3 days a week, and then that gave me enough money that 2 days a week I could work on startups. So I was working on a startup with a friend of mine who lived in New York, and then a separate startup with a friend of mine who lived in Australia. And it was all like mobile, very early mobile apps, SMS-based apps. And I learned a lot from both of them, but ultimately they didn't really go anywhere. They both failed, but very cool experience. So then I decided contracting was fine, but I generally prefer working for a company and being a bit more invested in what they do. So I decided to look for, another company to work for full time. And it was in the Netherlands at that time, I think after the dot-com boom had ended and turned to a bust, a lot of the companies that were left, I didn't find them that interesting. So I must have interviewed with 5-10 companies, didn't really find anything I liked, was at a bit of a loose end, like what to do next. And I'd worked for a content management company for a while, and I'd found that so boring. I was like, I just don't want to work in another boring job, right? And then I had an ex-colleague of mine who sent me an email with that basically saying, like, there's this job in London, it's probably your dream job. So aside from tech, my other big passion is music. And the job was at Last.fm, which was all about, music and tech. And it looked so interesting, completely right up my alley. So I applied there, did some interviews, got made the offer, and it was like, okay, here we go, London bound.
And what made it just so exactly what you wanted, other than the music?
I guess it was music geekery, right? Because Last.fm was all about, so one aspect of the site was about streaming music and being able to listen to music, but the other half was all about tracking everything you listen to, and based on that, because there were so many millions of users, they could build recommendation algorithms. And even just yourself, you would get your personalized charts, what you've listened to in the last week, month, year, and get all of this information about your listening habits and genres and artists. And it was just so like this geeky side of like tracking all of your music, and then what you could get from that was also really appealing.
I think it's worth pointing out, correct me if my memory is wrong, this was pre-Pandora as well. So this whole being able to have specific recommendations, I think it was the music industry that was really doing that recommendation early on.
Yeah.
And it was the very first one. So that was all very novel, getting songs recommended to you, things happening automatically like that. So yeah, that was peak geekery at that time.
Yeah, it was amazing.
And so you made that move to London, and is that when you really started getting into data?
Yeah, so that's the funny thing. Like, I thought I was joining a music company. So coming back to what we said at the beginning, but it was actually a data company. So they were actually the first company outside of the US to use Hadoop. So, and it was just I'd never heard of it, right? I joined there, and the first thing I was tasked with working on was, I think the first thing they gave you as a new join on the tech side was like, build a Hadoop job here's all of our data, build a Hadoop job that does something interesting. So, I did something that, looked through users skipping songs to produce like their most hated songs instead of their favorite songs, something silly like that, right? But that was just my first experience with MapReduce and big data. And a lot of what they did was building charts and feeding recommendation algorithms with these massive amounts of data. And they had tried doing it before. So all the catalog information was stored in a Postgres database. But they found that if they were trying to generate charts, using the data from Postgres, they would also be feeding the database the website. The UI was obviously reading from Postgres to put things on the page. But if they then generated the charts in a batch at the same time, the website performance went down. So they're like, no, we need to separate these systems. And Hadoop was a perfect fit. So they would dump all the data out of the database, all the listening data, and then they would process it all offline on a Hadoop cluster and then feed it back in again at the end.
Which became the pattern at that time.
Yeah.
We do our offline batch processing.
Yeah.
And there was no good real-time systems at that point.
Nothing. Yeah.
So you either, there was really nothing out there. I mean, Storm came later on.
Yeah,
even
much
Storm
later.
didn't quite do right.
No. And what was really funny there, because they did charts, so we would release the charts on a Monday morning, so everything would need to start processing on like a Sunday night. And then if something went wrong, you would come in on a Monday and maybe the jobs had failed and they would all take hours to run. And then all the users would start complaining, it's Monday, where are my charts? And you're a bit like, hang on, map reducing, wait a few hours. So you always had this pressure on a Monday morning when you came in, like, have all the jobs finished or not? And if not, then you have to like go fix all of this stuff.
That's pretty funny. Your users are actually that invested in your data because...
Yeah, there were some very passionate users of that site. It was amazing.
Oh, wow. Okay. I don't think I ever got that deep into Last.fm. I'd listened to it, but I don't remember going through their data at all.
Yeah, so I mean, there were people who used it to listen to music, but there were also people who were just so into the data side of it.
And you said that you're a musician, you love music? What?
So I'm not a musician. Wish I was. I used to DJ. So like playing music in that form, and also just listening to a lot of music.
Okay. And your DJ name was?
My DJ name was DJ Mass Dosage. So that's still like my internet handle these days.
Okay, that explains it.
Yeah.
So when you messaged me, I thought, what the hell is mass dosage?
Yeah, a lot of people wonder that.
And you were a mass dosage of what?
Yeah, and it has different meanings. So the name actually came before, but there was a slang where I studied where if you would insult someone, you would basically say you were dosing them. So then like dosing the masses became kind of a thing. But it was just about doing something kind of at a big scale would be the other way to look at it, right? A mass dosage.
You were doing big data or big dosing all the way back before it was cool?
Yeah.
Okay. In fact, one of the people I used to work with at Cloudera, that was his tagline. Been doing big data before it was cool.
Yeah, nice.
You've been big dosing before.
Before, yeah.
All right. Well, so were there last up were some of you said it was the first usage outside of the U.S. of Hadoop.
Yep.
And that would be pretty early on then.
Yeah.
And so that actually is the first time I think I ever saw anything about you was you wrote a chapter in Hadoop, the Definitive Guide.
Yeah.
Tell me that story.
Yeah, so Tom White, who wrote the book, he lived in the UK. And because we were such early adopters of it and doing it at such a big scale, we actually knew a lot of the original committers. Like Doug Cutting came to London. We ran the Hadoop user group in UK. I forget some of the names, but basically nearly all of those early developers, we spoke to them or they came to London. And so we got to know Tom because he lived close by. And then he said, yeah, I'm writing this book. Would you guys like to contribute a chapter just on what you're doing, how you generate your charts and all of that? So we had another guy, Mark de Pelon, the Spanish guy. He was working on our chart system at the time. So he knew much more about how we'd implemented the charts. But English wasn't his first language, so we decided to collaborate. So, he did a lot of the conceptual stuff, I did a lot of the writing, and it became a chapter at the end of that book.
Yeah, and the rest is history. That was the very first big data book, as far as I know.
Yeah.
And there was no, and so when I got into Hadoop, that was the book I read there. There was really no documentation about it. It was...
Yeah, I mean, when we were using Hadoop, the only way we could figure stuff out was to go look in the code. There was nothing. No one could help you with anything. I mean, there were papers, like Google had obviously published their famous papers about the theoretical underpinnings and how MapReduce works. And there were a few things like that, but they're quite academic. So you could get the concepts, but if you were actually like, now, how do I program something to use these things? You had to figure it all out yourself. And that book was definitely a lifesaver in many ways, because you could actually now start getting some reference on what people are doing, what the patterns are, what's the right way to do things, the wrong way to do things.
So to be that early on is interesting. It's very rare that people will have that experience of being that early on. What was surprising about that being that early on?
I think a lot of what I'd done before, like if I was using like an API, like something, it would have been delivered by a company like, let's say, Microsoft or some other vendor. So you would get documentation, you would get help, and you could mostly rely on it to work, not always. But with this, like, there was no documentation, there was no vendor behind it. It was a complete open source project. It was quite chaotic. And there was lots of stuff missing. And this was like my real first experience with open source. It was like, well, if it's missing, no one's gonna help you. You might wait, but if you want it, go add it yourselves. And it was, in some ways it was annoying. It was like, oh, why do I have to do these things? But in other way, it was empowering. So there was some feature in Hadoop missing where you could have like a job depend on other jobs. And I think the being able to reference them went one way, but it didn't go the other way. So I did a contribution to fix that because we needed it for something. It was a tiny contribution. But the fact that I could actually do that was like kind of game changing. It was like, oh, wow. And then you could see the collaborative power of all of these people working on this.
Yeah, as you were talking about that, my memory immediately flashed on Doug Cutting saying contributions welcome.
Yeah.
And it's kind of odd how that's changing a bit. I'd say, where the contribution nature of open source, especially in the data side, it's 99% vendors driven, and that user contribution is significantly less. It's not gone completely, but it's far, far less.
Yeah, completely. I mean, obviously it depends on the project. There are still more like grassroots ones, but you see a lot of that vendors who either built a thing or started a thing or have just ended up using a thing, then end up having the majority of the contributions. And yeah, sure, they will accept other things that meet their vision, but sometimes they don't.
And that is the other big change of what's happened in open source. Your contributions are welcome as long as they fit that narrative, vision, path.
Yeah.
Which is odd. That wasn't what the foundations were looking for.
Yeah, I think the foundations, I mean, they also obviously had opinions and agendas and would only accept certain things, but I think it was more like if you could prove that you needed something and it didn't, the people behind the project would just be like, fine, let's add it. Without necessarily thinking, does this fit what we as a company behind this project are doing? It was more like, it felt a bit more merit-based. You could just be like, I've built this cool feature, let's add it. And generally, as long as it was some level of quality, even sometimes not even a level of quality, let's just add it.
Yeah, there wasn't the as high of a bar.
No. I mean, if you look inside some of those, like Apache big data projects, I mean, I've looked inside the Hive code base. There is some unbelievably shocking stuff inside there, but it works, and lots of people used it to do lots and lots of stuff.
So we were talking about that difficulty of using Hadoop early on. And part of what I don't think people appreciated, I know I was I was early on at Cloudera, and what I don't think Cloudera realized was the weirdness of writing things in MapReduce. That it was a completely different way that you wrote code, way that you solved problems. And I was trying to tell somebody one time that, and I was saying, no, this is, I've written a lot of code. This way that you're having to break down the problem is very different. I think in terms of, okay, I do this map, that I do this reduce, or the other big one was most probably for you and for me up to that point, our interaction with data was a database.
Totally.
Database sorted out all of these difficult problems of a group by
Joins.
and then joins and that sort of thing. I didn't have to think about how do I join. So how did you go about figuring out these weirdnesses? Because there wasn't much documentation about how you even do a join at that time.
Yeah, I found it hurt my head a lot because you were having to fit things. Like MapReduce is an amazing paradigm for certain types of task, but we were then starting to put things on top of it that probably should never have been put on top of it. And that then forced you to really think about like doing joins and like introducing these sort of artificial keys. And you would have to like do all of these steps for something that's in a database would just be, 2 lines of SQL. And now you're having to write 100 lines of Java to do something. And that I definitely found that very frustrating and thinking this is kind of a waste of time. And it felt very unnatural. So I did not enjoy that aspect of it. Like taking every line in a file and doing something to it, amazing. Distributing that work out, because it did all of that for you, right? Like it did the hard work of parallelizing it across hundreds of machines and gathering the results again. Like that was amazing. But then when you started trying to layer on more and more complex logic into these jobs, that was a real pain.
So you said it hurt your head. What was the most head-hurting one back in the day?
I think I've got like PTSD and I've wiped it from my memory. But yeah, I think what we also had a lot of was, we would like having like the concept of like what we would now call a DAG, that you could model it much more simply as like a flow of data. We would have to build all of those things ourselves. So do some crazy logic, dump it to some intermediate thing, and then layer on another step and build up. And then you would have to have in your mind, all of the steps at every time and figure them all out. It got very, very complicated. And we also sliced and diced the data in a lot of different ways, by time, by genre, by user. And it was just all of these different ways of grouping the data. And the other thing was a lot of the jobs were very, very similar, but just that little bit different that you couldn't reuse the code. So that made it also, very challenging. Like code reuse was very hard. And unit testing also wasn't great for those frameworks when they first came out.
It was pretty non-existent at that time. Yeah, it's kind of crazy bringing back some of those memories. So in many ways, the early Hadoop code, especially the MapReduce code, was taking out removing a bunch of the best practices that you had of code reuse and good abstractions. And you basically didn't use classes. You didn't use inheritance.
No.
It was almost procedural code that you were writing.
Yeah.
And the only time you would really break it up would be maybe you'd break up some methods within it to kind of make it a little bit more easy to understand.
That's all you could do. And I'd gotten very used to everything you just talked about in previous jobs. And unit testing, amazing. And now suddenly I couldn't easily test my code anymore. And you couldn't use types really. Like everything was primitives, obviously for it to be very efficient. And I remember like strange patterns, like you wouldn't create an object every time. You would just refill its values so that you wouldn't get all of that churn on the JVM and the garbage collector. So things like that. It's just a very different way of thinking about things. And anti-patterns became patterns.
Yes, unfortunately. Well, so the Tom reached out to you about writing that book or writing the chapter, and that was when you and I originally met. So the TDG came out, the definitive guide came out in 2009. We probably met 12?
Something like that.
Something like that. Yeah. So you weren't at Expedia yet. You were
Still at Last FM.
yeah, you're still at Last FM. So what I really miss about the conference scene now is that there isn't that same sort of, I guess, excitement and same sort of closeness, or that hot core of that there was with the Strata conferences. The Strata conferences, I don't think we're going to see something like that again. I do miss it.
Yeah, me too. I mean, I remember starting with the Hadoop Summit before Strata, and that was, originally like only a few hundred people who were into all of this stuff going to San Francisco. Pretty sure Yahoo must have sponsored a lot of it. And there it was just everyone was actually like, I could talk to other people doing this stuff. And it was just all about swapping war stories and knowledge, because all the things we've touched on, like, there was no documentation. We didn't know, like, is this the right way to do something? Is it the wrong way? So all of that data, that knowledge sharing was really, really good. And then when Cloudera came along later, and Hortonworks, and then we had Strata, it was just a lot of people just sharing what they'd been building and why. And you would go there to learn and just have like lots of really, really good discussion. I mean, people had agendas, but I think mostly the agenda was just about, we're building all of this new stuff and how do we get it to work.
And it was at that time you started doing more public speaking, and you made a conscious decision to start public speaking.
Well, no. So that's talk that I gave where I met you in New York, how that came about was just crazy. So I think his official job title was Vice President of Product at Last.fm. So Last.fm got acquired by CBS Interactive, the big American media company. And he had given a pitch to a talk, which was all about like, how do you manage privacy in applications that are actually gathering a lot of data about people. And I mean, music data is not as sensitive as a lot of other data sources are, but there was definitely, people were thinking a lot about, like, with the advent of big data, like, what are people going to do with and people were starting to gather more and more data. So he pitched a talk on that topic. And for various reasons, we had, reorganizations inside Last.fm, and he left, but the talk had been accepted. So I had a very good relationship with him. So he said when he left Last.fm, he said, I would like Adrian to give this talk. And we had a discussion about it. And I met with him a few times, and he kind of gave me the outline of the talk. But I had never signed up for this. But it did make the most sense, because I was kind of like a more senior person at Last.fm working with data and touching on a lot of this stuff. So I got sent to New York to give that talk, but it wasn't my idea.
But you said that at the same time you made this decision to say, I'm either going to keep doing this and get better at it or stop.
Yeah, so what I found with public speaking was I kind of like preparing the material and the slides, and then as it got closer, I would get more and more terrified. And then on the day itself, I would just be an absolute wreck. Like, so nervous, wouldn't be able to eat. And then I would give the talk. And then if it went well afterwards, I would just feel like amazing. Like, yes, smashed it. You're kind of on this high. I'm going to do this all the time. And then a few months would go past, and then maybe you'd get signed up for another one, and then it would start all over again. And so it definitely did not come naturally to me. Like some people, it does. So I made a decision at some point, because so when I joined Expedia, one of the things we wanted to do was raise their sort of profile in the tech community. And one way to do that is to give talks on what you're doing. And we were doing a lot of interesting stuff. We were contributing to open source projects. So it made sense to talk. And I decided one year, I'm going to do talks for this year, whichever ones I can. And if by the end of the year I've conquered my fear of public speaking, great. If I haven't, I'm never going to do this again. I'm just going to be like the developer who maybe writes blog posts or does other things, but I don't need to be out there in public. So that was a kind of a goal I had for the year. And by the end of it, I was fine with public speaking. But it could very have easily gone the other way.
But do you still get that fear, or did you conquer that fear?
I think it's pretty much conquered. Like I've given other talks since then, and it's fine. Like there's a little bit of nervousness, but nothing like what it was before.
Okay.
Yeah.
So that is something I do recommend developers especially think about. Like it may be surprising, but I have a pretty good background in public speaking even before I started developing. I didn't realize how that could be used, or that could be used, or that could be valuable. And so I had conquered my fear of public speaking as a child. And I didn't realize that people would actually want to hear me speak or want to hear me talk about something. And so it was a bit of a shift of learning that there was such a thing as a developer evangelist, such a thing as somebody paying you to go speak at a conference. That was just mind-blowing to me of, somebody will pay you to go speak at a conference. That sounds like fun.
Yeah. Yeah, I mean, for some people it'll be fun. For some people it'll be a nightmare.
Yeah.
But I think it's good to find out where do you sit on that. And it's definitely, I mean, developers are, generally more introverted people, probably don't enjoy these kinds of things. But I agree with you. It's like, give it a shot. If it works for you, amazing. It opens up different avenues for your career. But also, you don't have to do it. There are plenty of other things you can do.
There definitely are.
Yeah.
That's the part I would try to get people watching this to think about. There are lots of paths. One path is go heads down and become an even better coder. That is definitely a path to go down. And then there are other paths where you're not letting your code go and your coding skills go. I still code, and I love coding. And I do tell people that, but I also love interviewing and hearing these stories. So there's a lot of different paths that you can go down. Just don't think about that one path you have to go down. You can take some of these skills that you have, and you being able to be a really good coder and speak. You didn't have to be the world-class speaker. You didn't have to give a TED talk. But even just being a little bit better as a speaker, it adds this brand new world for you. So I'd encourage everybody to think about that.
Yeah, completely.
Well, so from Last.fm, you went to Expedia, and you started working on hotel data. You talked about how hotel data is different, but how was that, or a lot of it's similar, but how was that different as well?
Yeah, so the first thing we started working on there was SEM, so search engine marketing data. And obviously, like a company like Expedia, and specifically it was hotels.com, one of their brands, they obviously do a lot of SEM, so bidding on keywords and then wanting to see the performance of those. So they would have like several 100,000 keywords and then get these massive reports on how all of those keywords performed. So again, it was all about going through these huge volumes of data and grouping it in certain ways and filtering it in certain ways. We also worked with they called it clickstream data. So it's basically people clicking on different pages on the website and then being able to build the customer journey over time. Where did they come in? What did they look at? Did they buy something? And then they would do things like A/B testing, multivariate testing. If we change things, do people go this path? Are they more likely to book a hotel? So obviously all of those use cases are very specific to a hotel like an e-commerce platform that's selling hotel rooms. But the underlying, how you would actually process all of that data, it was the same in many ways as someone on tracking all the artists that someone had listened over time and summing it by that or grouping it by an artist. A lot of the data munging was the same, even though the data was a completely different type of data.
Patterns are the same.
Yeah.
And so by then you'd come into your own knowing the patterns of, okay, this sounds like this pattern. Boom, boom, boom.
Yeah.
Okay.
And also by then people had started building frameworks on top of MapReduce to abstract it away from you. So I think the first step was MapReduce. Then people put other things on top of it to abstract it away, but under the hood it was still MapReduce. So we had Hive, which was obviously SQL, and Expedia was a massive SQL shop on the data side, like nearly all companies were then. And they had, big IBM DB2 set up. Loads of people have written lots of SQL. So for them to move that data out of DB2 onto a distributed file system and then operate on it, it was natural for them to use Hive with SQL. Cascading had come along as another way of building a pipeline programmatically, but under the hood it turned into MapReduce. So it simplified things as a developer because you now had a different way that you could abstract things away. You could build more reusable components, less so with Hive and SQL. And then slowly people started adding testing frameworks to at least make that better.
Yeah, those were the days. But I would say, I don't think we've learned as much about unit testing as you'd think.
Yeah.
And we still haven't said, yes, we unit test first. That's still not happening.
Yeah. I think where I see that still the most problematic, and I don't understand because SQL's been around for decades, being able to do like good tests on SQL. Why not?
Well, yeah, I think it comes from the sort of mentality of people are thinking that SQL is a one-off there. You get there, you type in your query, but that isn't what the vast majority of what SQL is.
No.
This query that's running several times a day.
Yeah.
We expect this output.
Yeah.
We expect this.
Yeah.
Well, now you have your next startup idea. So you alluded to it before, but you were talking about this open source working group at Expedia, and you were trying to get people understanding that more. Tell me about your contributions to open source.
Yeah, so what happened is at Expedia, we were obviously a lot of what we're building on top of is all of the things we've just talked about, which was open source. So we could contribute to them. So we'd kind of got into that, more comfortable with that model. And because there were such big Hive users, they were really pushing it to its limits. I'll give an example. Like they had different business units that had data stored in different places, but using Hive. And if we wanted to join the data from those different data sources, having just one Hive metastore is impossible because it's modeling the data there. You've got a metastore there. So we actually we went to a DataWorks conference and we had a chat with Alan Gates, who's like the project lead for Hive, and kind of explained all of this to him. And then one of my colleagues at the time had this idea of basically putting the metastore in front of the metastores and then pointing it at different metastores. So it's almost like you've got a proxy onto different metastores. And I remember Alan being like, that could work. We're like, okay, well now we feel validated. Let's go build this thing. And I mean, it's nothing to do with Expedia's core business of travel. So they were very happy for us to open source it, to get other people contributing to it, but also for them as almost like a marketing tool for people to come work for them. Okay, look, we build these cool tools. We've got an open source profile. So we started off just building those things for us to use and then open sourcing them. And we had a number of projects over time. And it was initially very, very challenging. They hadn't open sourced anything in their 20, 25 years of existence. So we were the first team in Expedia to open source something. And it was a huge battle to get the first one out the door. But after that, it became much easier. So that's kind of how it started. And because our team had sort of championed that, it just kind of snowballed into like anyone in the company doing open source started chatting and reaching out. And then we very fortunately had a leader, like the CTO of hotels.com, who was very supportive of all of this. And then he kind of championed this idea of having a working group and everyone working on it together and having it be, I mean, it wasn't my full-time job. I wish it was. It was kind of like a side hustle, but it was something they had us do, and it definitely had value, and I really enjoyed it.
It sounds like that champion is key.
Yeah.
That C-level champion. Yeah. Otherwise, you'll get log jammed at this level, manager or something like that.
Legal department. Yeah. Anyway, like that, definitely.
Okay. Yeah, it's kind of interesting. What you're describing as now called the semantic layer. In fact, on the show, I interviewed somebody from Q who does a semantic layer, and it's interesting how we see those patterns of, yes, your metadata needs to differ from mine. How do we separate that out? And it's interesting. So you, from your LinkedIn profile, it looked like Expedia is still using, at least as of 2021, was still using Hadoop. Is that the case?
Yeah, they still use. I mean, it's the underpinnings of, because they still use Hive.
Oh, really?
Yeah. I mean, they've got a huge investment in it. They've got a lot of code running in it. But they also moved on to things like Spark. So they do data processing in Spark. But I mean, a lot of those things are still, if you look in the innards, there's still going to be some Hadoop libraries underpinning it, right? They're still in there.
Yeah. Yeah, that's kind of funny. I told people this, is that something, when it becomes enterprise software, it never goes away completely. There'll always be someplace, somewhere using Hadoop. It's not like you should let your skills atrophy, definitely, but it also is that you are going to have, you will get a call in 10 years saying somebody saying, hey, can you fix this Hadoop job? Or it may be in the government somewhere, some government office that didn't modernize.
Banks, I'm sure banks are going to be doing this for a long time to come.
But I was also going through my book, my data team's book, and there was a point that I made in there that I'd forgotten I made, and I was saying, it's in the preface or the introduction, I say, you're not going to get 20-year lifetimes out of big data technologies, and you should know that. And for that time, it was pretty revolutionary me saying that, because the vendors were saying, yeah, here you go. Hadoop forever. And then it became Spark forever. And it becomes, okay, yeah, we're not going to get 20-year timeframes.
I wonder if it will stabilize at some point, because you're completely right. Those things, I mean, Expedia doesn't do MapReduce anymore. They do Hive. But I don't think they're necessarily married to Hive. It's just having a SQL layer on top of a massive amount of data. That's ultimately what they want. But I think those things, like you said, change. You know, there was Storm, there was Spark, there's Flink. But I wonder at some point if those things will become more standardized and stabilize, and then we'll have a longer shelf life. I don't know.
I think it's going to be, we'll have SQL, but it's going to be like we were just talking about with the web browsers. There's going to be this quirks mode, and that quirks mode of, you're running your query on whatever system, Spark with Hive. Oh, it has this quirk, it has this bug, and you're wanting to run that over here. So I still think that you need to understand the underlying system, like Druid, let's say. So is your data all rolled up for you, so you don't have point access? We may be speaking SQL, but I've always told people you have to understand that technology underneath the covers, otherwise you're going to use it wrong, you're going to misunderstand it. Or you might have dealt with this, people thinking Kafka was a SQL engine or a relational database. Oh God, how did that happen? Well, I know how that happened, but if you think of it as a relational database, oh my goodness, you are never going to use it correctly.
Yes. I could see how people would want to think it was a database, but it's not. Yeah, that was a crazy project. We probably shouldn't talk about it.
Why is that?
we might offend whoever created it.
Well, when you say something like that, that means you have to talk about it.
I mean, I remember looking at that project and being like, cool. I don't want to treat Kafka like this. I want to treat Kafka as, a big distributed, stream of data. That's fine. That's the way to think about it. And I can do my SQL abstraction elsewhere.
Yes. Yeah. Well, so you won't have to say it. I've always said from the beginning, KSQL DB was really terrible from the very beginning.
Yeah.
In fact, I have a post. You can see it. It's probably 5 or 6 years old. Me saying exactly that. Sorry.
I have to apologize again.
Yes. You can apologize again.
Let me just quickly check what he's saying here. I can't stop there. If you work to a point, I'll send it'll be easier. 5 minutes walk. Yeah, that's fine. All right. Looks like it's recording here. All right. Yeah, so can I just apologize to your viewers and listeners for my terrible handwriting and drawing skills. It's definitely not one of my strong points. Ever since I was in primary school, my handwriting has been awful. Both of my parents have pretty bad handwriting, so I kind of blame them, and there's probably nothing I can do about it at this point.
That sounds like a cop-out. I'm not judging, I'm more pointing out in a passive-aggressive way. No, I've seen worse. I've seen worse, definitely. So you went from Expedia and you went to Human. Why did you go into security?
Yeah, so I've always been interested to a certain degree in security. So in my first job working at that touchscreen kiosk company, one of the things we were looking at towards the end was being able to do payments over using the kiosks. And the networking layer we were using was just HTTP with no encryption. So the software package we were using didn't provide HTTPS. So we actually started thinking, I built out as a proof of concept, we never actually used this in production, an encryption layer. So on the client, we would encrypt things using a standard encryption algorithm, and then on the server, we would decrypt it. So I've always found that interesting, and I've always had like an interest in that area of software development, but I've never done it. And so that looked appealing, and just the general idea of wanting to make the internet a better place by stopping fraud, stopping bad actors, which is a lot of what Human does. All of that ticked a lot of boxes for me in the more interesting side of things. But the other part of the role was it's a data platform team. So it's like I can what I didn't want to do was throw away all of this data experience that I've got and do something completely different, like mobile development. Like I'm sure I'd find mobile development interesting and I could do it, but I'm quite attached to data and data processing. I really enjoy it. And why throw away 10, 15 years of experience? So it was kind of a continuity because it's still data platform, but then it's something different because it's security and fraud.
On your LinkedIn profile, you say that you're using Kafka and Snowflake.
Mm-hmm.
And you're doing this at pretty large scales. What are some of those challenges you're hitting?
Yeah, so the scale is absolutely huge. And a lot of the challenges are actually just around how much it costs to do things. So in the past, at smaller data volumes, you had challenges like, can I process the data fast enough? Can I store enough data? The kind of flip side of where we are today with some of these systems being like infinitely scalable is that you can scale up Kafka horizontally to huge degrees. An object store like S3, you can store a lot of stuff in it. A system like Snowflake, you can scale up your data processing pipelines. All of this, you can pretty much scale it horizontally as much as you want, but it comes at a cost. So one of the big challenges is we could gather 100% of the data and shove it through all of our systems, but they would need to be at such a huge scale that it would just not be worth the money for it. So there you have to start thinking about intelligently, like selecting certain parts of the data or sampling the data and storing things for less. So there's a lot of the things you used to have to worry about, like, I have to put another node in the cluster. That's gone away, but it's now like I have to deal with additional cost, and how can I actually reduce that?
So did you explore any of the newer ways of dealing with Kafka, for example, Warp Stream? Stream Native has another one where it basically goes directly to object store.
We have looked at those things. just theoretically. We haven't actually even done any proof of concepts. For our use case, we want the data in Snowflake. So it goes via an object store to load it into Snowflake, but we don't want it just on the object store. We want it in Snowflake. So those don't really help our particular use case.
I see. So it's getting it into Snowflake. And then you also have that issue with Snowflake of you can't really do UDFs well in it. How are you handling that?
What do you mean by you can't do them well?
Well, as far as I know, there's not even a good way to write a UDF in Snowflake.
You can. So you can write them in Python, JavaScript, or Java.
Oh, you can now?
Yeah.
Okay.
Yeah.
And they're executing on their hardware?
Yeah.
Okay. I didn't know that.
The thing I don't quite understand, and I haven't dug enough into it, and Snowflake obviously as a platform abstracts you away from what's happening under the hood. What I'm thinking is, if I've written it in JavaScript, like what's the underlying engine written in, right? Like if it's in Java and I've written a Java UDF, I can picture some Java code on every line of data coming out of a table running my UDF. But if it's in Python or JavaScript, how is that happening? Like, is it doing an out-of-process call for every single row? Or is the engine written in Python, and then we've got the reverse with the Java thing? That's the magic. I don't know how it happens.
Yeah. Yeah, I actually explored this. I don't know if you looked at it, Grail, Graal.
Oh, GraalVM, yes.
Yes. And how you could natively compile Python into it.
Yeah. So are they doing something like that in the background? I don't know.
I don't think so, because it didn't seem like it was a lot of people knew about that. It took some digging to find that.
Yeah.
But yeah, it was interesting. So now we're at the whiteboard portion of this, and we don't have video of this, but for various reasons. So let's talk about, normally in this show, I interview somebody who is the founder of some technology or works at some technology place. And so they are talking about how whatever they works.
Mm-hmm.
So now the question to you is, in your bevy of NDAs, but at the same time, your vast knowledge of how things work, draw us some pretty pictures of how things should work.
How things should work. I have to think about this for a minute, because there are a lot of different things we could talk about.
Well, how about we get started with that early on, because it's so relevant to now of how are things working for Last.fm.
Yeah, so I guess there were some interesting things back then that you could think about, and then wonder whether we've still got some of those. I guess one of the things is, if you know all of those things now, it'll maybe prevent another generation of developers from making some of the mistakes we did, especially because back then those things weren't really mistakes, they were patterns, because we had certain limitations, and like a lot of those limitations are gone today. So like an example is something like HDFS, so like a distributed file store, which we had to like run and maintain ourselves. Now you have something like S3 or GCS or whatever, where you almost have like infinite storage. Well, it's an object store, so it's a slightly different pattern, but you can kind of think of it like a file system. So there are a lot of things you don't have to think about anymore, to a certain degree. Let's have a think. My drawing skills, I've got absolutely awful handwriting, so don't judge me. You can always feel free to tidy up something I've produced.
Okay. I do that sometimes, and you get deducted points every time I have to touch it up. I
might go into negative territory there, and I'm fine with that. You might make it look nicer. So, yeah, how did things work back then? Is there like a database type of a symbol?
I'll just draw it out.
Okay, we'll just do that then. So,
you got to select it. You didn't.
Oh, sorry. So I guess like the root of a lot of things back then was your database, right? Relational database. And this would store, all information about like every artist, musician, every album they'd made, every track they made, and you'd have IDs joining them. And then obviously you would need to having just one wasn't good enough because it couldn't handle the load. So you would have replicas, which we just call it DBR, DBR. And then, because those replicas couldn't keep up with everything you needed to do, what did you have to put in front of them? Cache.
Yeah.
Of course. And then this would satisfy like a lot of your read cases. So then you could serve your, I'll just draw a squiggly thing here. This is the website and everyone else. I told you my drawing was ugly. Huh? So you have all of that going on, like serving your live traffic and everyone interacting with the website. But occasionally, obviously, people would need to write. So if they created a new artist, for example, so that would have to skip all of this read stuff and go in this way. So this would be a write path. And then you would have to push all of those changes down into or invalidate your caches and your read replicas. So obviously keeping all of that in sync was an absolute nightmare. And it's one of those famous, the hardest things in computer science, naming things and caching.
Yes, it is.
So now we have, those replicas are effectively caches. You've got your cache. So there's all of that going on. And then, we have our data processing, right? So what we need to do at a certain point in time, if we're going to generate those weekly charts, let's just use that as an example, we do like a big dump of all of that data onto HDFS. I'll kind of draw it like that because it's obviously many nodes, right? And obviously this is just what we use there in HDFS. It could be any distributed file system, right? So that manages, the fact that you've got replicas of data on different machines and all of that fancy stuff going on. But now you've gone from having a relational model on the left-hand side where you can do joins and stuff to basically just flat files, like CSV files back then. Obviously, later on, we had Parquet and ORC and all of those other things layered on top of it. And then we would have our processing engine, so MapReduce. So let's just say, should we just do like a silly example of counting the number of listens for an artist?
Sure.
Yeah. So do you have a favorite musician? Who would you be listening to?
I have quite the wide range. I think it would be hard for them to recommend. Let's go Luciano Pavarotti singing La Traviata.
All right, so let's just say we've got Pavarotti, and he's got artist ID 1.
And the next one should be NoFX, because the people there's a high crossover of people who listen to NoFX and Luciano Pavarotti.
So do I write it like that?
Yeah.
Yeah.
I take it you aren't a fan if you don't know us.
I don't. I don't listen to either of them. I know Pavarotti, but that's cool. So very simply, you would have a file with that as your artist ID and the name. And actually, when you're operating at this level, you actually probably don't. Whoops, sorry, where's the erase? You actually don't even care about the artist names in this case, right? You just have their IDs.
Yeah, it's just the number.
Yeah, so we can actually just get rid of that. But obviously there's all more to it than this, but just... so this is our artists. And this is their ID. And then we might have another file, which, because we're not modeling it relationally, we denormalize things, right? So it'll be like, let's just call it user listens. So this is how many times a user has listened to an artist. So it'll be something like, we've got a user ID, we've got an artist ID, which obviously refers to that there, and then we've got a count. So we might have something like...
So that was a rolled up count. That wasn't single.
Well, in reality, we would have actually a line for every single I mean, we could do it like that. I mean, the way it would be modeled would be exactly like what you just described.
It's basic. It's like a click stream or a play stream, probably is what you called it.
So let's say you're user 300 and you have artist ID 1, you've listened to it once, and yeah, exactly. Your user again, artist ID 1, you've listened to it once, and obviously there's timestamps and all kinds of other stuff that we. And then this is maybe me, I'm user 400, I've listened to 2 once. And then you would need to run a MapReduce job, which obviously sums up the counts, right? So, I mean, what gets abstracted away from you is the fact that these files are living here on HDFS. And this artist thing actually isn't even used until potentially right at the end. And you might not actually even need it. You just need these user listens with the artist IDs. So then you would then do your MapReduce, which would effectively group by user ID, artist ID with a sum. So in this case, we would produce, user 300, artist 1, account of 2, and then user 400, artist 2, account of 1, etc. And then that's your, let's say that was a week's worth of data that you've extracted there. You would then, roll that all up, add all of these up, you've got your sums, and then you could say at the end of the week, user Jesse has listened to, order them by the count, so that's another round of jobs, order them by the count, and then you've got your charts for yourself. So that would be yet another MapReduce job. I haven't even written how we would do all of those jobs, right? But that you'd be chaining all of these MapReduce jobs, one after the other, to do the sum and so on. And then you'd have all these different variants of it. Like, this is artists. We would also then have the tracks that you've listened to, or the albums that you've listened to, or the genres that have been listened to. And you might slice it at the user level, or you might slice it at, a region level or a genre level. And you're basically just working with all these matrices of numbers and then running them through all of these MapReduce jobs to aggregate them and group them in different ways. And then I guess the final bit would be this all then has to go back into the database. So the final step would then try sort of normalize this again so that it fits back into your model in the database and then can get shown to the users on the left-hand side.
Yeah, and this was some of the problems that we had, especially early on, was right here for the how do we chain jobs? There was no good way of doing that. Your runner, you would have to do that yourself in the runner, and that was a pain right there, because it wasn't so much hard code wise, it was more hard error wise. Do you retry? Where do you
retry? Where do you resume from? Yeah.
Yes.
Yeah. I mean, yeah, exactly. When you chain those things together, you would often write intermediate output here to HDFS, which would then get used by the next job. And then right at the end, something would need to go back and clean all of that intermediate stuff out, because we didn't have infinite storage back then. You definitely needed to get rid of that stuff. And if something broke somewhere, good luck figuring out which of those steps you needed to replay and where you could safely resume from and where you couldn't. Absolutely no concept of transactions and checkpoints and none of that stuff.
And you can also see right here, this is a good place where SQL will do this really well.
Yes.
You can define this job, and you're counting. That's a very easy sum, and the breakdowns by user, those are all just keywords.
Yeah.
But what I find the issue is, not every job is going to be this straightforward and easy. We're starting with this one because this is the hello world of Last FM. This is not the one that's maybe up here or somewhere else here in our stack where the DAG becomes really hairy.
Yes.
And then you need code.
Yes.
And this is one of the things I've been that the data influencers and people who talk about this do not talk about. And they say, look, here, this is all easy. Just go right here. You can do this all with SQL, and that's fine. But your problem, you're not going to pay somebody a lot of money for this. This can be written with SQL. You're going to pay somebody a lot of money who can do this one down the road correctly.
Yeah, and what you see with SQL, like you said, all of the stuff that can be expressed using SQL, like group by sum, count, all of those things, that's fine. But you often need to perform much more complicated logic on the values themselves. This is just showing summing and grouping, right? But a lot of data processing pipelines need to transform data in various ways. Take a value from here, take another value from there, join them, maybe run them through some kind of an algorithm to generate another value. And that stuff's impossible to do in SQL. So you either have to use a different framework or you need to start writing like UDFs or stored procedures. And then, which is fine, you can do that, but that's starting to become a lot harder. And again, we get into like, how do you test those things and how do they perform at scale? What are their characteristics in terms of how much memory they use, how much processing they use? When you need to do joins, that's always an expensive thing. Can you fit the things in memory? Can't you? And I mean, even using frameworks like Spark and Flink, which make a lot of this easier, and you can write much more expressive code and do these more advanced things, you then often get bitten by, you run it in production, and suddenly like one of the data sources you're pulling in you'll run out of memory. Or things that often people don't think about at all that really gets you is the way those frameworks work is they obviously have to distribute your compute logic across, machines in a cluster. And they have to use some characteristic in the data to do the distribution. So a user ID, for example, right? So in this example, a silly one would be if we distributed the work, this counting work across 10 nodes by a hash of the user ID, that's fine. But then you've got, user 500 who's listened to millions of songs. Suddenly one node is processing everything for user 500. Everyone else is finished. You've got massive skew. And now your job is slow. And those kinds of things, if you're just thinking about it simply and you don't understand actually what's happening under the hood, you'll just be like, no, why is my job taking so long? And there's only one machine running it and you've got no idea why. Maybe you haven't thought about how you model those things. So yes, there's a lot more to it.
There is a lot more to it. And you would have that. So if you were doing a group by artists, you don't just have a Pareto, you have the Justin Biebers.
Yeah.
You have these Justin Bieber-esque problems.
Yeah, totally. So you need to, if you know how all of this works, I mean, that's where the challenge comes in. Like, a lot of this stuff is easy to do at a small scale, but it's when you do this at a really, really big scale that things like this become an issue, like skew and running out of memory and the characteristics of one data set being very different to another. Now you're joining them. And obviously things change over time. And what we see a lot, like in my current job, which is like cybersecurity, there are a lot of like peaks and troughs in behavior as adversaries try to figure out systems. They will do things like send weirdly shaped data to a system or push it to its limits by sending a lot of data in a short period of time, and then they'll go away again. So you'll have a data pipeline that works perfectly, and then every now and then, because the data you're dealing with indirectly comes from an adversary and they're testing your system, trying to figure out all the boundaries, suddenly you'll hit these weird conditions that maybe only last for like 15 minutes worth of data and then they go away again and you never see them again. But you have to build a pipeline that's resilient to handle all of those things, which is super challenging.
Well, let's talk more about Skew. Go to the second one there. So go. And would you mind drawing out more about Skew? Because I don't think people, especially the new people, understand that.
Mm-hmm.
And I think especially the instruction that's being done on data systems is not covering Skew at all.
Yeah, okay, so let's say we have like 4 processing, what can we call them, worker nodes. So we're going to get this to fit in here. worker 1. Can I just do W2, W3, W4? And I guess we go back to our simple example, right, of like, how are we going to split this? So what was it? We had our user ID. Oh my God, that's a terrible view. Artist ID, and then the listens. So should be a button I can push to create a table. So, let's just say we've got user 300, artist 2 has listened once. So we decide, okay, let's just be really, really simple. Let's just take the first digit and we decide, okay, we can't process all of this data. So obviously this file here goes on for like, millions, if not billions of rows, right? We obviously can't process all of this on one machine. We need to distribute this. So we need some way of distributing the data across. We've got a cluster here of 4 machines at the bottom. So let's just say we take the first digit. This is just simple for the example. So everything for user ID is going to go onto worker 3 because it's 300, right? So if we only have, you listen to 1. So what we effectively have to do on this machine is sum up for user 300, all of their listens. So obviously this is trivial because it's just a counter that you're incrementing, but perhaps you actually need to track more interesting stuff for user 300. Like you need to store a lot of data. So maybe it's a list of all the artists they've listened to, for example. So you would want to keep track that they've listened to artists. Yeah, so let's say we're doing that. So in this case, they've listened to artist 1 and artist 2. But now along comes user 500, who's listened to artists, 1, 2, 3, 4, 5, 6, 7. Like they just listen to everyone. And this might even be a crawler of some sort that's sort of trying to span your catalog by going through all of your data and listening to everything once. So now, okay, well, let's just say artist user 500 goes onto 4. So now we've got and now we're counting all of the artists they've listened to. So it's 1, 2, 3, 4. So that's going on. So obviously, however long it's going to take to count all of these artists is probably like an order n operation. So if user 300 has only listened to 2 artists, we send this data to the different nodes. So this gets all the artists user 300 has listened to. It's just 1 and 2. So we're finished. They've listened to 2 artists. We know what they are. We're done. But meanwhile, what's happened in the background is on worker 4, for user 500, we're now having to send them, let's say all million artists in our catalog. So everyone else is probably finished, but now we just have for one user this job just taking forever. And it's all skewed on this user over here because of their behavior. So, what that'll typically look like if you're looking at the resource usage on these nodes, the CPU on this one will have finished, and then this one is just sitting there carrying on all by itself. And you're wondering, why is my job taking so long for just one thing? And it's because of the skew.
And this is really hard to log, because if you start logging and you say, oh, I'll just log out the number for every single one.
Yeah.
It's now you have a log entry for every single one, and you can fill up the disk like that.
Yeah, completely. I mean, logging in distributed systems is like classic. It's super challenging because the volume is just so high. And if you log everything, you're almost like duplicating all of the data that's moving around again. And then where do you send it? How do you view it? How do you aggregate it? It gets super expensive. And if you store it on the disk on the same node, yeah, like you said, you run out of disk, or you shove all of the log stuff over the network, and then your network usage goes up.
So what did you end up doing to deal with skew like this? Or is there something you can do?
Well, in an example like this, I mean, there isn't really much you can do because you do have to distribute it by that user, and you put the work there. I mean, I guess you could I wouldn't do this. It depends. If you actually need all of that information, you could do something horrible like, I'm not even sure how the framework you would do this, but you could try send 500's work to 2 nodes, but then you need another step to kind of bring it together again. What I think we would often do is, like I said, depends on your situation, but in this case, it's quite possibly abuse. So if someone's abusing your system and they've put it in a state, so if someone's actually listened to 1 million artists in a week, like, is that real behavior? Almost certainly not.
But so whether it's real or not, your system needs to handle that. You can't have an out of memory exception. You can't.
No, but what you could do in this case is we would often have to put guardrails in place, right? So on the processing for user 500, you might just say, I'm going to cap this at 2,000. And if you've listened to more than 2,000 artists, it's like, sorry, I'm stopping. And then you basically just abort that job and you accept no further input.
So you put a horizon on it and say, okay, that's it.
No more.
No more. Okay.
And we did do that because we had we were talking earlier about people being so massively obsessive about listening to music. And we would have people, so we would have a chart for a user. So the top people who listen to Taylor Swift. And obviously, like, the big Taylor Swift fans want to be number one on that page. So what do? They abuse the system by writing a script which just pretends to listen to Taylor Swift 24/7. And then we're just getting all of this information about this person because they want to be number one on the Taylor Swift page on Last.fm.
I'm sorry, that was me. I'm sorry.
So I remember having to deal with that problem and basically having to put things in place where we just had to, like, come up with so there was an algorithm for submitting listens where we basically said you had to listen to at least 30 seconds of a song. So we then calculated what's the theoretical limit in a week. So basically 30 seconds times a week, you get a number, and anything above that, you just throw it away.
Okay. Did you play around with any of the approximate quantiles or approximates?
Yeah, so now you've actually made me remember what we actually did in this case. So that was first solution, was you would just cap it. But then obviously all of those crazy Swifties would all be capped at the same number. So I can't remember, like, I'm not a data scientist. We had some very, very smart people back then. We didn't call them data scientists back then, but they were data scientists.
They were smart then, or they're smart still?
I'm pretty sure they're smart still. We just didn't call them data scientists then. They had some kind of a function that you could apply to this kind of data to basically, like, if, someone's claiming they listen like this, it would actually flatten it out there. So there were functions you could apply to basically just flatten things out and to get rid of these, like, extreme outliers and just be like, you know what, I'm just going to cap you here and I'm going to ignore it. And you wouldn't have to do all of these other calculations. So there were things like this that we would apply to the data to stop abuse. And then I guess coming back to what you were saying earlier, like, this example is simple because we started off just talking about counting things. And now we're talking about applying statistical functions to the data. And that's what you actually end up having to do. And that gets much harder. And yeah, modeling a statistical function like this, you probably can't do this in pure SQL. You're going to have to then pull in a library or a UDF or something else to do it.
Yeah. Or you do something that has a built-in, like Druid has approximate quantiles built in.
Yes.
Approximate sums.
Yes.
But those weren't available back in the day.
No, they weren't. Exactly.
So maybe it's a question to what we were talking about before. Does having to know this make you a better data engineer now, or do you think is it like most things where you just you don't need to know it now, it just doesn't make a difference?
It definitely makes a difference. I notice when I mentor or teach junior developers and we give them a fully fledged system today, they don't need to know a lot of the details, but if they don't know those details, they can make mistakes, or they can end up in situations like this and not understand what's going on. And yeah, maybe they don't need to have been in the trenches and had to have experienced all of this and built it up from first principles. But I definitely find when they run into problems and they get stuck and something's running out of memory and they don't know what to do, and I kind of get called in as like the distinguished engineer who's kind of done this before. And then I explain to them, maybe I'll look at a problem and I'll realize it's, maybe it's the skew pattern, for example, since we've been talking about that. And I'll be like, it's this. And then I explain to them like what's going on under the hood, like what I've just drawn here about how this data processing gets split across nodes. Because I know that, I can solve the problem. And then explaining that to them, they also have an aha moment, like, oh, wow, I had no idea that this is what happens under the hood. This is how it gets distributed across the cluster. So I think it definitely makes you a better engineer to understand the principles. And I'll go right back to that first job I had when I joined as a developer who'd been to university. I had a computer science degree, and I'd studied a lot of the theory behind computer science. And there was a developer at the company who'd been there for like 5-10 years, and he had never gone to university. He'd learned everything on the job, and I mean, he was an excellent developer, super smart. But we would like work on a new project together, and I would like pick something up quicker than him. And he was like, I'm so jealous because you have all of those principles. You can like pick these things up much faster than me, even though I've been programming twice as long as you have. And he was like, he could really see not knowing a lot of those fundamentals. It just took him longer to figure things out. And it's not because he was stupid. He was super smart, but he just didn't have the principles. And I think that's exactly what you're seeing here. If you don't have the principles, if you don't know what's going on underneath, you can be super smart, but you will get tripped up. And there are things like putting in all of the work and understanding, I think, what pays off in spades.
Well, let's go to whiteboard 3. And so what would you mind diagramming out a hairy problem that you dealt with at one point and how you solved it?
Let me think about this a bit.
Sure.
I've got a few crazy ones. We need to choose which one we want to talk about.
The craziest, the cray, as my kids would say.
Yeah, I can think of one because this was an absolute nightmare to figure out. So again, let's stick with the Last of M because it's a place that was very open and happy to share a lot of the stuff that we built there. So there was another layer of complexity on top of all of this, which is like a legal framework. So Last of M didn't just, you could just send it information about what you were listening to on a device, but you could also listen to music that Last of M provided, like Spotify does today, right? You could stream from there. And there were a lot of rules set by record labels, collecting societies, all of these different entities in the music industry, which would be like, you could listen to this artist in this country, but you couldn't listen to this artist in that country, right?
Okay.
So, and then we would send reports to the record labels on what had been listened to where, because depending on what had been listened to where, we had to pay different rates for that. So they would basically send us a dump of their catalog, and they would say like, let's just say our friend Taylor Swift, right?
You can admit you're a Swiftie. I judge you.
I'm not. Okay, we'll put here an artist I really do like, Kendrick Lamar. So they would say, okay, you can stream Taylor Swift in the US, Canada, and let's just say Germany, right? Well, And then maybe Kendrick Lamar, you could listen to him in like the US, the Netherlands, and I don't know, whatever, South Africa, right? And there was a lot more to it than this. There would be rules for like, on a desktop, you can do these things. On a mobile device, you can do these things. So it would get really, really complicated. So we would, kind of what I was showing before, we would track, Kendrick Lamar was listened to. So let's just say she's artist 1, he's artist 2. So you could think we could build a report like artist 2, some track that they've made, track 1, has been listened to in the US 5 times, right? And, artist 2, the same track has been listened to in the Netherlands 2 times. So we would send this information back to the record labels and they would figure out how much they need to charge us. So what we noticed is we were sending them information like this. Kendrick Lamar, track 1, has been listened to in Canada 4 times. So we're not allowed to stream Kendrick Lamar to Canada, right? So we had a whole system in place that would basically, you would come along and we'd be like, okay, cool. We're going to recommend you some tracks. So we're going to build a playlist for you. And we see Jesse is in the US. So we're going to recommend him. What are we allowed to do? We're allowed to give him Kendrick. We're allowed to give him Taylor. What were the guys earlier? NoFX?
Yeah.
So let's say they're allowed in Germany and the Netherlands and not. Okay, so NoFX was allowed in Germany and the Netherlands. So Jesse comes along and we know you're in the US at that point in time. You were there. So we're like, okay, cool. We can play you some Kendrick, we can play you some Taylor, but we cannot play you any NoFX. So we build you a playlist with songs by Taylor Swift, songs by Kendrick Lamar. And so we're respecting the rules that we've been given, right? So that's fine. But how come we find that Jesse's been listening to songs in Canada? Like that should never have happened. We should never have done that. So the way and we would send these report backs. So this was happening. And it was just like, does not compute, because we would look at the playlisting code that generates this, and it very clearly looks at the country you're in, looks at our rules, and only picks artists that you are allowed to listen to in that territory. And obviously this is happening on a massive scale. This here is happening minuscule, like less than a percentage of the time, but it is happening enough for it to be labels complaining. So it's like debugging a distributed system is incredibly complicated. And then trying to reverse engineer what happened. I mean, it's almost impossible to like trace the paths of everything that's going on. But what we did notice is that we had a little bit more information in that when people were listening to songs, we had an IP address into a geo lookup. So, that's how we could tell that you had listened to something in Canada, even though that should never have been possible. So then what we had to do is basically start writing some custom jobs to like find one of these examples and look into a little bit more what is going on. So what we would see is, here you are listening to a song and you're in the US at, let's just say 2000. And then we would see you again listening to a song in Canada at 2005. And then we would see you listening to a song in the US at like 2007. So now it's like, okay, what's going on here? And then we would actually find some information about the device that you're on. And we would notice that this happens when you're on when you're on a mobile device.
Somebody knows their GPS and cell tower triangulation.
Exactly. So what happens is when this playlist gets generated, you are in the US. And then you're driving along, or you're on a train, or whatever it is, and you're on the border near Canada, and then you switch over, and you're now listening to the song that was allowed in the US, but you're on a Canada tower. So that is exactly the problem. So we then had to implement in so basically the player would get that playlist and basically just blindly trust it because it's been verified and it would trust it. So now we had to introduce logic that every time you moved on to a new song, it would have to double check where am I now? And have I moved from where the original playlist was? And if so, I then have to X out all the songs that are no longer allowed. So now all of this like logic that we'd nicely put in the playlisting service now has to move to the player service. Or what we actually did to simplify, because we didn't want all of that logic in the player. If you moved countries, we would just nuke the entire playlist and create a new one for where you were.
But sometimes when you're at the border, it can really bounce around.
Yes. Yes.
And what happened to those poor users? Did they call up and say, why are you nuking my list all the time?
Well, fortunately for them, the playlist wasn't visible. Or fortunately for us and them, I guess.
Oh, because it's Last FM was more of a radio station.
Exactly.
Okay.
So this is all in the background. So what we would do is we would just generate. So our playlist service got more hits, but it was fine. This doesn't happen that often. And the user would never know that their playlist had actually changed under the hood.
Oh, yeah. Yeah, in fact, the reason I know this off the top of my head is you deal with this with planes sometimes in airspace. That GPS is not, when you're flying a plane, your GPS is accurate, but it's not as accurate as you'd like it.
Yeah.
Because you're going so fast. So you're making a pretty good approximation.
Yeah.
And so you could think sometimes pilots will actually get infractions of moving into airspace that they're not supposed to because of a GPS error. Or, there's all kinds of crazy things that happen with that. But it actually brings up an important point that I've been thinking about lately, is that data is not data in and of itself. It's not, when we go to debug a problem, it's not, well, here's a fact. This was played with this. No, when we have to go debug a problem, we have to look at the data. We have to look at this other people's data. We have to go look at our code. And we have to look at the physical world of what's happening everywhere around us.
Exactly.
And this is what makes data difficult.
Yes.
It's not necessarily the distributed system. It's not necessarily this or that. It's the fact that when we go to debug, we have to go through the entire thing.
Exactly. Oh, yeah. This was super hard to figure it all out because we had to touch the digital rights system, the tracking system, you're drawing this much better, the playlisting system, and the user moving around in the physical world and like tie it all together. And this required talking to different teams, different departments, different technology. So being like a data sleuth for this one, putting it all together and understanding how all of this data flows through all of these completely different systems was super challenging.
You brought up the other part that I forgot to mention, and that is when we're dealing with data, it's not just here we interact with the player team. It's, we're here with the team that interacts with the record labels in this case, and there's probably some kind of rep there and so you as the data engineers are having to go talk to the player team, talk to this team,
the legal department,
all these places that probably you've never had to deal with before. Now you're having to deal with them as a data engineer. As a software engineer, you didn't deal with these people. As a data engineer, you once again are all over the company, all over the data, all over touching all sorts of things.
And I guess part of that is because the data comes from all of these different sources. When there's a problem or an issue or even building a feature, whatever it is, you have to go to the owners, the producers, the consumers, you have to go talk to all of them. Whereas I'm sure the player team have their own challenges, but they could just focus on building a player.
Yes.
I mean, they do obviously have to think about, formats and all kinds of other, but generally they can build a player and they're good. They don't have to think about a lot of this other stuff.
Now that you've had all this experience and you can look back, what do you think we got right and wrong as a data? I should say as an industry. I think we're an industry. I still think that we're a new industry, even though you could say it's 15 years old or whatever. I still think we're a new industry.
Yeah, it's not a solved problem. What did we get right? I do think we've got a lot more flexibility in how we process data. Like, it pretty much all just used to be batch, right? So the fact that we can now stream data in a reliable fashion, and they're really good APIs for dealing with streaming data, it gives us more options in like the latency of where we need to do things. We've got more options than we had before, so that's really good. I would say overall, it's much cheaper to process massive volumes of data. Like, if I think back at the problems Expedia had when they wanted to massively expand their data warehouse, something like a centralized data warehouse built by IBM and DB2 was just prohibitively expensive. So this whole idea of being able to use commodity hardware to store data and process data has definitely democratized that and made it hugely available to all kinds of companies that didn't have access to it before. And I guess that's also driven like more companies are now actually data companies because they can do this, because they can afford to do it. So I think that's great. I guess there is more interoperability than there was before. Like, you're not tied into just your vendor's data warehouse. And obviously there is still vendor lock-in, and wherever a vendor can, they will try lock you in. But I think there's more of an acceptance. There is no one size fits all. And we need to be able to get data in and out of systems or have an interoperable format that they share. So that's quite interesting, some of the stuff that's happening there. So I think those are all things that are good. I guess one final thing is just some of the APIs for dealing with data. So obviously you've got SQL. It hasn't changed that much, to be honest. But if I think of like a programming paradigm for dealing with data, something like Flink is a much more natural way of being able to model data and build reusable components than MapReduce ever was.
Yeah, we finally gotten more maturity. I've always been wondering if I don't think we're at the point where this is the last system or it'll never be supplanted. But this time around, Flink and Spark have been around longer. They've iterated more.
Yeah, they've survived longer than Storm or Cascading or some of those other frameworks.
Yes. So speaking of that, what do you think the future of data is?
I mean, as much as I like wizards and crystal balls, I'm not one. I like to think that there will be an easier way to share data across different systems. So like Apache Iceberg as an example, this concept of trying to build a way of modeling data, like schemas and partitioning your data and being able to evolve your data, all of that has been too hard, and being able to like reason about backwards compatibility when you change data. So all of those things that's sort of trying to solve, but it's also trying to solve it in a way that you could bring different systems to the same data and have them interact, so sharing that metadata. I really, really hope we have more of that, so you're not locked in to a system. So there's definitely been progress in that front, and I really hope we have more of that. A lot of the power on the vendors and where the money is it's kind of a double-edged sword for them, because on one hand, they don't want that because they want to lock you into their system. But on the other hand, the reality is if you want your users to be able to, users want to be able to potentially use different systems. And then it's in their best interest to support something like that. And I hope that's the side that wins out. So yeah, I guess more interoperability, more standards, and like this concept of a table, it not being locked into, you know, a Snowflake or a Redshift or whatever, just it being more like an abstract concept, so you can model your data and then share that model in different systems. I would really like to see that.
I've also wondered if what things we're gonna come back around on.
Yes.
So you see these cycles in the industry, and I wonder if one of those cycles is actually going to be this object storage of saying, oh, we actually need that back on local disk. So it will be an HDFS similar sort of thing where we say, oh, okay, well, we measure out our bottleneck is now data, you know, or we're pulling data from over here, data from over there. Do you think there's any other coming full circle things where we'll go back to?
I mean, the classic one always is like, do we federate all of these systems and have something that can like talk to all of the different things? Or do we just centralize all of it in one place and just have one way of doing it? And I saw that at Expedia over time, like the architecture moved from centralized to federated, and then it felt like it was coming back again. So that's a classic one that I think every like 10 years, I don't know what the time period is, but that one's a classic one that goes back and forth.
I think the one that I think is really going to happen is the coming full circle on microservices and monoliths, where I don't think people quite understood what they were doing with microservices. And unless you're a distributed systems engineer, you didn't understand the Pandora's box you were opening with a microservice. Guess what? You now have to handle RPCs and errors. And you're not in the same process anymore. And oh, by the way, now there's logging, and now you have to log between these microservices.
Yeah, network bottlenecks.
Bottlenecks and all these things. And I think we'll have this. Maybe it won't be as monolith as, you know, the single monoliths. Maybe it'll be several monoliths. But I think that we'll go back to that and say, oh, wow, look at how fast this thing performs. It's no longer a 10 millisecond round trip. Now it's milliseconds.
Yeah, completely. There's like the modular monolith, right? That's the thing that gets talked about. And that's one of the things I've worked on at Human is exactly that. We have a service that does different things. But the way it's been built is it's just one service. But it's composed of 5 effectively libraries. And the libraries are separate things. They get developed separately, tested separately, everything. But they just get brought together in the modular monolith. And I think it's a great design. Each of those separate things could have been a separate microservice. It would have had all of those problems that you just described for actually very little benefit for this particular use case. They don't need to be separated. But you can still separate the development of them, the evolution of them, but the monolith brings them all together in one place. And I really like that architecture.
Yeah, I think we tried to solve our organizational problems technically, saying, oh, don't worry about solving how you work together as a team. Split up, and we'll handle this with a separate REST service or whatever service.
And I think for version 1, that probably works beautifully. But then as things change and then like team A decides to change their service, but now team B has to update their one, that's when things really start going wrong.
Oh, what happens? Well, I guess I have one last question for you. Do you plan to stay in data till you retire?
That's a very good question. Probably. Like I really enjoy it. I mean, I didn't start my career thinking I'm going to be a data person. I didn't even start my sort of path to being like a career path. I didn't even start thinking I was going to be a software developer. But I really got hooked. Like just working with it and just seeing the power of it and what it can unlock and just how it sort of underpins so many different things. Like that's super interesting. And kind of what we've touched on, like it can power so many different kinds of use cases. I find that really interesting because I don't see how it'll ever get boring. So there's the scale, and all of those kinds of things are interesting. Computer science challenges and distributed systems, amazing. But the fact that you can just apply those skills in like completely different fields. So if I ever get bored of cybersecurity, I could go to a completely different field, take a lot of my knowledge experience with me, be able to build things, but do something completely different. I find that like super, super interesting. And yeah, I could picture working with data for the rest of my career until I retire and open a coffee shop somewhere.
Well, promise me that you become grumpy at some point because of too nice.
Yeah, I'm definitely more skeptical than I was when I started in this industry. I don't think I'm ever well, maybe I'll become a grumpy old man, but skeptical, yes, but grumpy, hopefully not.
Okay, skeptical. You mean you aren't going to believe everything the vendor says? What's happened in this world? I can't believe it. You heard it here first. Vendors lying to people. Never happened.
Never happens.
Never happens. Never ever. In fact, I now I remember that's where we got cut off before. We were starting to talk about a particular vendor that I was talking about, KSQL DB. Yeah, I mean, you can see the post I wrote about it. It was right there in the post, and nobody was really talking about it. And I thought somebody's got to talk about this. There was a lot of scuttlebutt at the conferences where people would say, their opinion, but nobody would actually come out with it. And there's this weird problem of, I'm worried about how this has some sort of backlash, or how does this happen to me? So there's people knowing something is bad, or it's a bad idea or whatever, but they're worried about, or even the microservices we were talking about. If you said anything about microservices 10 years ago, you're old.
You're an idiot. What do you?
How could you know, or how can you think these things? So there definitely is, as I'm starting to talk to more people, there is definitely an ageism of you get on this bandwagon, you stay on this bandwagon, and you don't rock that bandwagon. You go along with it. Kafka is the brand new thing. You did not say anything bad about Kafka. we're becoming 1984. But yeah, it's unfortunate where if we can't have rational discourse about something, that's when you should be really afraid. And that was when I got really scared of people saying Kafka everything. I was like, oh God, no. God, no, please don't do that. This is a very specific thing.
Yeah, it's amazing for certain things, and it'd be an absolute disaster for other things.
And now we're kind of experiencing this with AI and thinking, okay, AI everything, Gen AI everything, generate your code for everything. And
definitely not.
Hey, there's a pretty bad fall off on this. I've written a decent amount of code with AI, and some of the worst bugs I've hit was AI. I didn't look over the AI generated code close enough because you get complacent, and there's definitely a complacency that happens.
Yeah, if you just give it a once over, you're like, oh, that looks good. But if you look into the details, there might be some really big surprises indeed.
Yeah, the Gen AI does not understand some of the nuances of data. That was what I realized yesterday. Some nuances to my data that they're in the code, but the Gen AI did not pick them up. So that's a really important part that, hey, maybe we still have jobs. Hopefully we still have jobs in the year.
I'm pretty sure we will.
Well, Adrian, thank you so much for coming on the show. Apologies to everybody watching this and saying, hey, there's some weird cuts. There's going to be some weird cuts in this. So I apologize, but this is the first one, and I'm hoping of many where as my friends come out to Portugal, that we can sit and talk, or as I travel to a conference, we sit and talk and we do this interview and have a lot of fun. Adrian, thank you so much.
Yeah, thank you very much for having me. It's been great.